Today, we're diving into something pretty amazing in the world of AI, how machines are finally learning to connect the words they read to the images they see. It's like we're giving AI a form of sight for the very first time. Let's jump right in. So, to really get a handle on this breakthrough, we first have to talk about a fundamental problem, a kind of digital blind spot that's been holding AI back for decades. All right, let's start with what seems like a simple question. A computer can process the word car. Sure, it can even spit out a dictionary definition. But does it really understand what a car is the way you and I do? Does it get the look, the feel, the whole idea of it? This slide just lays it out perfectly. You see, for the longest time, AI has lived completely on the left side of this screen, in a world of pure text and symbols. It's got the definition down, but it's totally missing the real-world experience on the right. This gap? Well, it has a name. It's called the symbol grounding problem. Think about it like this. If you can't connect the word car to the actual sight of a car, your understanding is just incomplete, right? It's kind of like knowing every single fact about an apple, but having never actually seen one. So, how in the world do we fix this blind spot? Well, the solution is this incredible new way of building an AI brain that can, for all intents and purposes, finally see. Okay, first things first, we need to get the foundation. A traditional knowledge graph, or KG, is basically a giant digital brain. It's a huge web that connects concepts and facts, like Paris is a city, and the Eiffel Tower is in Paris. It's all based on text relationships. This is where it gets really cool. We've got this super smart digital brain that understands how words relate to each other. So what's the next logical step? You give it a pair of eyes. And here it is, the big aha moment. This is a multimodal knowledge graph, or MMKG. It does exactly what we were just talking about. It takes a concept from that digital brain, like the Eiffel Tower, and links it directly to pictures of the actual Eiffel Tower. All of a sudden, the symbol is grounded in visual reality. So how do we actually build one of these incredible things? Well, it turns out there are two really fascinating and kind of opposite ways to teach an AI how to connect words and images. You can go one of two ways. You can start with a picture and ask the AI, hey, what do you see here? That's going from images to symbols. Or you can do the reverse. You start with a word, like dog, and tell the AI, go find me pictures of this thing. That's going from symbols to images. All right, let's break down that first method. This one is basically like showing an AI a photo and asking it to play a game of I Spy with everything in the frame. So, an object recognition model scans this image and starts pointing things out. It's drawing little boxes around everything it sees and labeling them man, woman, fire hydrant. Each one of those labels becomes a brand new connection in that big digital brain. Okay, now let's flip it around and look at the second path. Instead of starting with the picture, we start with the concept itself. We give the AI a word, and its job is to go out and find the visuals that match. Now, this approach works great for things you can easily picture, like a tree or a house. But what about more abstract ideas? I mean, not every word has a simple, clean picture. How does an AI find an image for something like, say, a physicist? And this is the clever workaround. For a concept you can easily visualize, like surgeon, the AI can find tons of clear images of people in operating rooms. But for a non-visualizable concept like physicist, it does something different. It might ground that idea by finding a picture of a really famous, representative example, someone like Albert Einstein. This is a perfect example of a visualizable concept in action. The abstract idea of a surgeon gets grounded by lots and lots of consistent images of people actually performing surgery. It's super clear, direct, and really effective for teaching the AI. Okay, so this is all really cool from a tech perspective, but why does it actually matter to you and me? Let's take a look at how this technology is already making the apps and services we use every day way smarter. Let's talk about recommendation engines. An MMKG helps them understand products on a much, much deeper level. So if you upload a new movie to a streaming service, the AI can look at the poster, see a spaceship, and instantly know it's probably sci-fi. It doesn't have to wait for anyone to watch it first. This totally solves that classic cold start problem. This is a great example. The AI connects the words amusement park to what it's seen in pictures, Ferris wheels, roller coasters. So if you happen to like a photo of one, it knows to recommend other similar experiences. The suggestions just get way more intelligent. And it's also a huge game changer for online shopping. An AI with an MMKG doesn't just see a product, it understands its pieces. It knows that a keyboard is part of a laptop, or what color a specific car is, just from looking at a photo. Look at this. It shows you exactly how it works. The AI can look at this image and build relationships in its digital brain. A keyboard is part of a laptop, a screen is part of a laptop. This opens the door for much more powerful and precise product searches. But maybe the most jaw-dropping improvement is in how AI describes what it sees. Instead of just saying, a man, an AI with an MMKG can tap into its huge knowledge graph, recognize who that specific person is, and give you a caption that's actually useful. This quote from the source material just says it all, doesn't it? The difference is night and day. We're going from a vague, almost useless description to one that's specific, accurate, and loaded with context. That right there is the power of connecting symbols to a deep well of world knowledge. So we've finally bridged the gap. We've pulled AI out of its text-only bubble and given it a way to ground its knowledge in the same visual reality that we all share. And that leaves us with one last big question to think about. Now that AI can connect what it reads to what it sees, what will it really mean for it to truly understand our world?